Okay, so our topic for today is Unit 2.1, Day 8, and this is Part B. And this is our introduction into complex numbers. So we've already kind of dealt with some complex numbers. And complex numbers are going to come what happens when we have imaginary numbers. And so we're going to kind of look at and reinvestigate what we were dealing with before when we talked about imaginary numbers. We're going to talk about how we can use square roots and kind of simplify square roots in order to identify complex numbers and how to manipulate and work with imaginary or complex numbers. So our objective today is we're going to identify complex numbers. We're going to write complex numbers in what their form of standard form. So we've kind of been dealing with a lot of standard forms, and I understand that there's a lot of standard forms to look at. So we have standard form of linear equations, we have standard form of polynomials, we have standard form of quadratics, and now we're going to have standard form of complex numbers. But the idea is we want a general way that we can write these, and so as long as we always write them in this particular way, we won't have any issues. And then the last thing that we're going to do is we're going to graph complex numbers, and we're going to see how it's a little bit different than our traditional coordinate plane. And then if you were looking at ways in which we use complex numbers, kind of in the real world applications, we use these in electronics, using alternate currents, electrical engineering, and quantum mechanics. Now for our class, we're just going to be able to use these to solve quadratic equations that we've already been kind of dealing with before, but have another way that we can manipulate them, or another way that we can represent them. And so one of the first things that we know is that we still have this understanding of what square roots are. So the idea of what we've been kind of learning over the last few lessons is that we have the square root of 25 is not only just 5, but it's plus or minus 5. We can look at the square root of 121 as plus or minus 11. And then the square root of 8 squared, we kind of looked at that before, is that square roots and squares will cancel each other out, and so this will just give us 8. Now notice that this is not positive 8 and negative 8. It's only positive 8 because of the reason of this base number right here. So we kind of go off of that. So if it was the square root of negative 8 in parentheses squared, then my answer would be negative 8. So only time that we get the plus and minus is if we actually take the square root, we don't cancel it out. Now what we will be investigating, as we've kind of looked before, is we looked at negative square roots. We know that negative square roots can't actually work, they don't actually happen, but we still want a way that we can manipulate them, and we still want a way that we can use them. So again, like I told you before, what we would do is we would take this, and anytime we see a negative square root, we would write I. And we would have the I times the square root of 16. But the idea is that when you take the negative square root, and we'll look at it in just a little bit, what this would end up being is this would end up being 4i. So we still take the square root, but we just kind of tack the I onto it, and we're going to look at why that is in just a second. And so now we kind of have the definition part of this. We're expanding our number system and using imaginary numbers and not just regular, what we call real numbers. And so the idea is that I is equal to the square root of negative 1. So anytime you take a negative square root, no matter what the number is, there's always going to be an I associated with this. Now what happens here, if you think about this, if I square that I squared is the square root of negative 1, what ends up happening is that I squared is negative 1. And this is going to be a very important thing to look at. So what I want you to do is I want you to star this. I want you to kind of make a note of this, because this is something that we're going to be using constantly. This idea that I squared is equal to negative 1. But the whole point of that is we're looking at this and we're going to say, okay, this is the only way that we can multiply two numbers together and actually get a negative answer, because that's really what a square root is asking for. Anytime you take the square root of something, you're asking what number multiplied by itself gives you that number. Alright, so the square root of negative real number, so anytime that we take a square root of a number that we know, so for any positive real number a, the square root of a, or the square root of negative a, is I times the square root of a. Now in some cases a can be a perfect square. We don't know that, but just so you know that I kind of always goes out in front. Now if you look back at the lesson that we did when we were looking at simplifying radicals, that perfect square always came out in front. And so we can kind of think as the negative one as being a perfect square. So I is kind of a perfect square. So let's take a look at what these look like. So the square root of negative 9 would be I times the square root of 9. So the idea is that we're just taking that negative 9, getting kind of rid of that negative, and just replacing it with an I on the outside. So I times the square root of 9. In this case, we know what the square root of 9 is, so I times 3. But we're going to flip that and we're going to write 3I. And so this is the simplified answer of the square root of negative 9. Now with the next one, the square root of negative 5, simply is just I times the square root of 5. Now we looked at in that last lesson that there's no perfect squares here, so there's nothing that we can do. So we're just going to leave it as it is. The next one, the square root of negative 144, is going to be 12I, kind of in that same fashion. Now we could write it out in this fashion, but I'm not going to insult your intelligence and tell you that you don't know what the square root of 144 is. The only idea is that we have to include it with that I. Now the last one is a little bit tricky. We have the square root of negative 12. We just kind of have to invoke our idea of simplifying our radicals. So the first step that we're going to take is we're going to say that this is I times the square root of 12. But we know how to simplify the square root of 12 now. So we have I times the square root of, looking for those perfect square factors, 4 times 3. So 4 would be the largest perfect square. Separate those out. So I times the square root of 4 times the square root of 3. And now I can go ahead and simplify a little bit. So this would be I times 2 times the square root of 3. Now I can just reorganize my work here and just look at this in terms of numbers first, and then I, and then the square roots. So this would just rearrange to 2I square roots of 3. So the idea of what we're going to do is we're going to use that whole idea of simplifying radicals, but also including I as part of that. Now you can wait to the very end if you want to do that and just throw in the I, but just understand that anytime we're working with negative square roots, I is always on the outside in front of the square root. So the first thing that we have is that we have the standard form of complex numbers. And so the idea of our standard form is that it has two pieces. The first part is this letter A, so this variable could represent anything that we want, and this is the real number part. So this is the part in which we actually know. So if it's a number, if it's a fraction, or anything like that. The BI part, where B it represents the imaginary. And I want you to look at two things. These cannot be combined. So it's not like we're going to be adding and subtracting like terms or anything like that. You're going to have a real part and you're going to have an imaginary part, and they cannot be combined. They need to stay separate from each other. Now the idea is that these can be radicals, these can be fractions, these can be decimals, these can be variables. They can be pretty much anything that they want to, but the idea is that we have a real part and we have an imaginary part, and they cannot be combined together. Even though they're numbers, and even though they're going to look like variables, there's nothing that we can do with them in order to combine them together, because you cannot combine real parts with imaginary parts, because if you think about it, it doesn't even really make sense. Now what we're going to do is we're going to simplify to our standard form the A plus BI. Now if you look at this, we just have to identify our different pieces. So the first part is that this is going to be the imaginary part. Now the reason that this one is going to be the imaginary part is because it's a square root of a negative number. And then here, this is going to be our real part. And we can go and look at those and we can kind of identify those. Now what we have to do from here is we just have to simplify each individual piece. So we're going to simplify the imaginary part, we're going to simplify the real part. We can add multiple real parts together. We can add multiple imaginary parts together, but we just can't add them across from each other. So we can't add imaginary and real. Alright, so if we look at this and we simplify this, we look at the square root of negative 121. So the square root of 121 is 11, so that means that this is 11i. That's our imaginary part, plus 8. Now if I put this in my standard form, I'm just going to go ahead and flip this around, and so it would be 8 plus 11i. And that's all I do. So I'm just taking those two parts, simplifying any square roots or anything like that that I need to do, and then just kind of flipping it around so that I have A plus BI, the real plus the imaginary. Alright, so let's look at the second example. I have the negative square root of negative 100. Now this one I have to be very careful with because of the kind of negatives that are involved. Notice that this negative here is on the outside, and I'm going to leave it on the outside until I'm all the way done. So let's look at just the square root piece by itself first, and then we can worry about that negative on the outside. So the square root of negative 100. So we look at the square root of 100. The square root of 100 is 10. Since it's negative, it's 10i. And now I have that negative out in front, so this becomes negative 10i. And then I have plus 11 on the outside. I just have to make sure the real comes before the imaginary, so I'm just going to flip this around and it's going to be 11 minus 10i. Notice that that negative stayed with the 10. It's not like I just got rid of it and just replaced it with the 11. The 11 is positive, the 10i is negative. And so that's just simplifying into our standard form of complex numbers. Now the last one is going to take a little bit of work on our part, so let's just focus on the square root part because that requires most of our attention. So the square root of negative 18. Now with that I know that there's going to be an I, so I can just kind of look at the square root of 18. The I is going to be out front. I need to simplify the square root of 18. I'm going to look for any perfect square factors that go into that. So we have the square root of 9 times 2. And that can split apart to the square root of 9 times the square root of 2. The square root of 9 I know is 3, so 3 square roots of 2. Now that I is still out there, so I have to make sure that I bring that down 2 as well. So I times the square root, or I times 3 times the square root of 2. Now I'm going to flip those around so that I can make it look nice. So this is 3i square root 2. So that's my imaginary part. So I had to do a little bit of work in order to simplify that, but the idea is that I'm using the same skills that I already have. I was able to take the square root of 18, even though it had an I with it, and simplify it to 3 square roots of 2. And then I just have to throw that I in there. So it's 3i square roots of 2. And if I bring this guy down, minus 2x, that represents our real piece of our complex number. Flip those around, so negative 2x, that goes with it, plus 3i square root 2. And so even though this looks a little bit different than the other ones, the whole idea is that we have a real part, the negative 2x, and we have an imaginary part, the 3i square root of 2. Now the last piece of information that we need to look at is we need to look at graphing complex numbers. And so if you look at this, we take our traditional coordinate plane and we just kind of make it a little bit different. And so our vertical axis is actually going to represent our imaginary axis. And our horizontal axis is going to represent our real numbers. So instead of x and y, we're just replacing it with real and imaginary. And so our complex number, they do not have ordered pairs. What they have is they have just their number. So in this case, I have 3 minus 4i. And so in a way, I can kind of translate this to become like a fake coordinate plane, where it would be 3 comma negative 4 for what we're used to. But if you look at it, we have this part here, so our real part. So we go over 3 and then we go down 4, but that's minus 4i. So in a way, it's still kind of the same way that we use our coordinate plane, but we're just understanding that we're talking about real and imaginary axes rather than just x and y. Still the numbers are the same, we still use those, but if you look at these are labeled negative 2i and negative 4i, and so when I say minus 4i, that means I'm going to go down 4 places in the imaginary axis. And we'll take a look at this too as well a little bit later. But the idea is what I can do is I can graph these. So this is my imaginary, and this is my real. So if I was to plot point A, it would be 6 plus 2i. And so the idea is I go 6 places in the imaginary. So 1, 2, 3, 4, 5, 6. And then I'm going to go plus 2i. So that means I'm going to go up 2 in the imaginary. So right here is point A, which is 6 plus 2i. Now in a way, like I said, these do not have ordered pairs, but you can kind of think of it as being 6 comma 2, if that helps you. but the idea behind that is that we're not using ordered pairs, we're using the real and the imaginary. So the next one would be negative 3 plus 7i. So I'm going to go back 3 and then up 7. 1, 2, 3, 4, 5, 6, 7. And so this is point B. That is negative 3 plus 7i. My next one is point C, so 8 minus 8i. So I'm going to go plus 8, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8. And so this is point C, which is 8 minus 8i. And then my last one, point D, negative 1 minus 5i. So I'm going to go back 1, and then 1, 2, 3, 4, 5 in the imaginary, or negative 5 in the imaginary. This is point C. So the idea is that we can still look at that as an ordered pair, but we're not going to actually write them as ordered pairs, but you can use those numbers as a guide to kind of tell you where those are going to be. And so that's how we graph complex numbers. And overall, this is going to do it for our introduction to complex numbers, our standard form, simplifying them, and then graphing them.